is the infusion approach that I've found most useful over the years in many contexts, and that is to look at your curriculum, look at the content, what's expected of students at the end of it, and identify what are the real-world applications of that subject content. Now, it may well be that there are no real-world applications, which will probably mean that you should not be using projects as an instructional strategy, because it will mean that the content is purely at the level of knowledge, recall and understanding, and not application involving more complex types of thinking. But let's assume that there is a significant component of your curriculum content that is real-world application-based. Once you identify what these real-world applications are, you then model those activities and say, well, hold on, what are the specific types of thinking that underpin competent performance in these activities? Now, as you go through that process, you'll start to see that those real-world activities will involve the types of thinking that we identified in episode 1, such as particularly critical thinking, analysis, compare and contrast, making inference, interpretations and evaluation. And in some cases, maybe even some creative thinking. At the end of the day, metacognition is likely to come in to any significant curriculum activity because it's about managing the whole learning process involving thinking, managing emotions and beliefs, etc. So let's have some practical examples. Here we go. This is that process applied to the content of an electrical installation design topic area. And as you can see, there's step 1 and step 2 there, which are about refocusing the curriculum towards the real-world competency, and then identifying the types of thinking that underpin competent performance in these activities. Now, the process to use, and it may take a little bit of practice, is what's referred to as cognitive modelling. And that is, you're basically asking this question: how does an highly competent person think in the effective execution of this activity? So if somebody has to troubleshoot a particular circuit system, how would they go about doing that? What are the big questions that they would be asking themselves? Because that gives an insight into the types of thinking involved. So if we look at the example on the right-hand side, here's a significant learning outcome, is that the student at the end of this module component will be able to use different types of wiring systems. So what would be involved? The student would need to be able to identify the attributes of wiring devices, compare and contrast types of wiring devices, and this is from the module document, evaluate the use of wiring devices and EIB technology. Now, don't worry too much if you don't understand the content, but you can see the process. And for reinforcement is another example from a business law module. It's exactly the same step 1, exactly the same step 2. It's cognitive modelling in the same way. And what we're looking at here as a significant learning outcome is that the student at the end of this topic area would be able to predict possible legal outcomes in the event of a breach of contract. Sure, you all know what that means. So, having gone through that process, step 1, step 2, cognitive modelling, these are some of the key learning outcomes, and you can see they very much focus on specific types of critical thinking, analyse the components of a contract, compare and contrast expected actual behaviour of defendants, make inferences and interpretations concerning the behaviour. In other words, well, if a person's broken the contract, what's likely to happen? And evaluate the possibility of specific outcomes. So, certainly something may happen, and what could be the specific outcomes so that the person concerned then has to make inference and interpretations about what they're going to do about these possible outcomes. So you can see here how this process works. So let's summarise this. Having gone through this process of refocusing the curriculum in terms of real-world competence or outcomes, identifying the underpinning types of thinking, we can now start to see that it's perfectly viable to write our learning outcomes in two main ways. One is focus on the type of thinking, like we saw in the business studies module prior, very much focused on thinking, and here's some more examples across different curriculum. For example, dealing with pollution, analyse the impacts of pollution on water quality, compare and contrast a range of retaining structures. That would be civil engineering. Now here's one for a different type of thinking, from critical thinking. Generate new design options for marketing a health food product. Creative thinking, right? Predict the outcomes of specific legal scenarios. Well, we looked at that earlier. That's very much an inference and interpretation focus. However, it's perfectly acceptable also to write learning outcomes in more performance terms. For example, if we look at the first one now, conduct product packaging tests for a specified product. That is very much a work-related competency, but underpinning that, there's got to be some critical thinking. Can you think of what that might be? Prepare a voyage passage plan. Now, that's a real-world navigation performance. I think there's a lot of types of thinking underpinning that. I wouldn't want that not to be well thought out. And so on with those other examples. So you can see, you can write these outcomes focusing on the type or types of thinking or particular performance product outcomes in your content area. And a final point of note at the bottom is that these learning outcomes can be written at different levels of specificity and contextualized accordingly. But the general concept of focusing on the desired performance applies. So it could be a thinking performance or a real-world performance that underpins thinking. I hope that helps. There's a little bit of thinking involved in digesting this, but you can play it over a couple of times.